I would like to welcome all of you to Behind the Code, the second edition. This entire thing is like an interesting experiment because we have people from multiple different programming languages stacks, and sometimes not even programming languages. Like we have like the data workshop guys, if I remember correctly. Yeah, there are people from various different technologies, and we can get together and complain about the stuff that we do. Because in every programming language there is something wrong, right? Yeah, so we get to share those faults. And Ruby is a niche programming language. It's a programming language that is most used for web application development. It's mostly bound to one framework called Rails. But today we'll be talking about AI, which is normally the domain of Python. So because of it, I will show some Python code, but please don't leave. All right, let's start. Do you guys know this company? Probably yes. They used to have this logo. Does anyone remember this logo, this specific logo from the very, very beginnings of OpenAI? Yeah, so they were iterating on it quite a lot. They started with this one in 2015. Then they switched to the one that's like more recognizable, still a little bit technical, with some like nice monospace font. Then they switched to a more generic one, and now they look like Uber or Facebook, because apparently every single company has to go into the same process of unifying the logo to this specific shape. But back when they were cool, they were releasing models for us to use. You can actually download the weights, you can do something with those models. And I know they kind of get back to it right now. We have the OSS models. They are not really that great, but they used to release the state-of-the-art models, like GPT-2, in 2019. A long time ago in terms of AI. And there is this quote from Wikipedia that back when they released this model, people were worried that, oh, this is actually too much for a CPU. We might use GPU, and it will be very costly to run this thing. It might take minutes to actually do something. So Hugging Face, a startup from France, they were doing like a Tamagotchi thing. They started doing their own version of GPT-2 called DistilGPT, using knowledge distillation. So it's slightly faster. And we had problems like that back then when the compute was actually something that they were worried about and not just throwing billions of dollars. But they were running those models. And now you can also run this model. You can actually train this model. This repository is called NanoGPT by Andrew Karpathy. And this is all the code that you need to train GPT-2 from scratch. It costs several $100s, so it's not as expensive. You can also do funny things, like you can change the tokenizer for something that is like, for example, one letter per token, which will result in GPT that speaks a very weird language that kind of looks like a language, but it isn't a language, because it will be just random words that kind of have the same structure as real language. By default, it ships with the words of Shakespeare, so you can do a model that will actually write new Shakespeare poem or a play. So yeah, you can play with this quite a bit. You can put your chat with your friends, and this will generate you some new chats with friends. If you run out of friends, it will be a new friend. It is written in the worst Python I've ever seen. It is really terrible, and one of the comments is, I just really dislike configuration complexity and having to prepend config to every single variable. And the guy actually does global variables, which are included and executed, just to configure this application. So everything is, every part of configuration is a global variable that you include. Truly terrible code, but it still works. You can actually create a working GPT-2 using this code. And it's not that difficult, it's not that long. It's a very interesting piece of software, even though it's written terribly. Now OpenAI is more like closed AI, and we don't have those things. But the truth is that you can't really stop something from being open for too long. You have open source movement, and they will make stuff open. They will recreate it from scratch if needed. And by the way, LLM models seems like a weird name, but ChatGPT made this, so it's large language models. But yeah, you can get some open models. You can get some decent ones. Mistral, or European French startup. Qwen, which is a model from China. Phi from Microsoft, which is from the time that Microsoft was actually fighting OpenAI for the rights to various different things that they do. Gemma, which is like a small Gemini from Google. DeepSeek, another Chinese model. Olmo, this one probably you guys haven't heard of because it's a very niche model. It not only provides you with the weights for the model, but also all the code that was used to train this model and all the data that was used to train this model, so you can fully replicate it. And they will even give you checkpoints for various different training parts. The problem with this model is that it sucks. It's terrible. I don't recommend it, but it's an interesting exercise on how you can open basically everything. There is Llama, which is open for most people, because most people don't work at Amazon, Google, and Microsoft, and NVIDIA. Llama is free if you have less than 1 billion users. So they specifically want to exclude some people from using Llama. But other than that, it's free, you can use it. There is Grok. You don't get the new one, but Grok 2 is something that you can try. And there are many, many, many more. And they have different uses, different parameters, different specification, and different requirements. But the fact is that there is actually a lot of variety. And you can pick a model for a particular use case and run it on your own hardware, which is really cool. But not everything is an LLM. There are different machine learning and AI models. We have, of course, embeddings, which are trendy because you can do RAG systems with them, you can do semantic search. Some of them are good for text, some of them are used for images, like Clip or Cyclip. Pretty fancy stuff. You have voice recognition. Whisper is the obvious candidate for the open model that you can use. You have image generation. There is a lot of stuff out there. Some of them are truly fascinating. But we're still in the pre-PostgreSQL era. And what I mean by that, right now, most of people will pick the biggest vendor there is, which is either Anthropic or OpenAI. It's like situation we have with databases in 80s and 90s. Everybody picked Oracle, because Oracle was the default. They only had like a working database, and nobody created something that is truly open and truly widespread, like PostgreSQL or MySQL. So we're still in this era where open models are actually not the default choice. You're not supposed to run them yourself. You're not supposed to pick the open one. You're supposed to pick the one that is provided to you by somebody else with very outrageous pricing and very, very restrictive terms. But we have stuff like Hugging Face, which I mentioned, which you can start using models, but also contributing to those models. If you fine-tune something, you can upload it. You can find models for various different things, not only LLMs, but also many, many other kinds of interesting models, which I will show you in a bit. But what about Ruby? This is a Ruby meetup, right? Like this part of the meetup is Ruby. So we can actually do something fancy. We can run quite a lot of stuff just in Ruby. And yes, you can do AI and machine learning in Ruby. One of the options is to go for wrapper gems, which is like the default way of starting work with foreign technology for most Rubies. I don't know, so some of you guys don't write Ruby daily, but Rubies, if they work long enough, they've seen this thing, which is basically a hack to have a jQuery bundled into your Rails application. Who still has this in their code, for those of you guys who write Rails? There is always some people who has this, like this is very deprecated, please stop using this, but yeah, it still exists. And we have similar situations for Whisper. You can actually just install gem Whisper, and it contains a native extension which will not only build the inferencing engine, but also download the model, and you have fully running Whisper in your Rails application. And this is how you run it. There is a little bit of extra code because of the format conversion, and I'll tell you why in a bit. But basically, you initialize the context, and you transcribe anything that you want, and you'll get the text. Not very difficult. There is, of course, Ollama, and VLLM, and Llama files, and LM Studio, and OLLM. There's like a bunch of different runners for, Jan is another one. There's a bunch of different ways to run large language models on your machine as a dependency for your code, and it doesn't have to be Ruby specific, but it's something that you can treat like a database or like a Redis engine or something else. It's something that is just part of your infrastructure that you can call without calling an external service. If you want to use Ollama, you can just do Ollama run Gemma 3 if you have Ollama, of course, installed, and you will have a working Gemma 3 with OpenAI API. So you can actually just swap your OpenAI calls for Gemma. It will work exactly the same, just without the API key. There are Llama files. Who knows what's a Llama file? Some people do. Llama file is a very interesting concept by its own, even without the AI part. There is this article, it was pre-AI, it was in 2022, or the pre-LLM, not pre-AI. Justin Tunney wrote code that allow you to use exactly the same binary on 6 different operating systems. So you have a file which you can double click and it will run in macOS, in Linux, in FreeBSD, and Windows. It will just work or anything. You just download the file, double click it, we'll give it permissions if you're on Unix, and it will just run. And if you bundle this technology, this magical technology, with something like Llama CPP, you suddenly have models which you can just run. You download the model, you double click it, and it runs, and you have a working model on your computer without any setup, without any extra special runner or special program to run this model. It's self-contained. So basically, this is a model that you can download and run as a program. You can use those in most of the libraries in Ruby that will support OpenAI. So of course, Ruby OpenAI, ActiveAgent, Ruby LLM, whatever else you have. And I would like to show you a small demo, which actually isn't mine because I've stole it from Pavel. Pavel sits here in the first row. I'll refresh this. Oh, and I already spoiled the surprise. So Pavel made this presentation that is basically a Rails application running in the background. And the application itself is pretty funny because it allows you to record some voice, send it back. In his version, it will send it to OpenAI for transcription. Then it will process with another OpenAI call to figure out which function you're supposed to call. And then we will send it over WebSocket to the browser and execute the code that he requested. And this is the way that you can talk to an animated dog. He called it Gem. Come to us, Gemma. But I renamed the dog to Gemma. And I hope this works because I never do demos. Let me try again. Come to us, Gemma. Fingers crossed. Come on. Let's try again. Come to us, Gemma. I really hope it's not the microphone issue because I saw the dog like a second ago. Not to worries. Maybe I can try if Ollama is running, or I can see if there is anything in debug for Gemma. Or I can restart the application.
If it's anything like my application, check the developer console in Chrome.
This is the developer console. It streams audio. Let's try it again. Come to us, Gemma. It will be super sad if a Gemma doesn't come to us.
Gem or Gemma?
Come to us, Gemma. So the difference between his presentation and mine, obviously his works, but I did this presentation actually twice, and Gemma was pretty reliable, so I'm surprised. Maybe it's environment. But the dog was renamed Gemma, and the reason why it was renamed Gemma is because it's running Llama. I tried Gemma, but Gemma doesn't support tool calls, so I couldn't actually get the dog to run on Gemma itself. I can also try one more thing, which is to come from the first slide to the second slide. This is his first slide. Come to us, Gemma. And if this doesn't work, unfortunately, we have to skip this demo and go to the next one. Nope, sorry, Gemma won't come to us. But the idea is that you can replace the very little code in his application with just one change to which model do you want to use and the other which URL you're supposed to call. I hope I can debug Gemma and I can show you afterwards after the presentation. So fingers crossed. But with just those two lines, you can replace a proprietary model with a free one, and most of the time it works exactly the same, just not this time. But you can go deeper. You can do actually more with those models. There is this thing called ONNX. ONNX is a short for Open Neural Network Exchange. It's one of the very few things that Linux Foundation and Microsoft agrees that is a good thing, because ONNX is a portable format for running machine learning and AI models. And you can run in any language that has our ONNX runtime. Ruby happens to be one of them. And you can actually do fun things with it. This is how you call it. ONNX runtime model new, you provide the path to the model, and predict, and you give it some input. An input is usually array of arrays of numbers. And you will get some other array. And the exercise to take your data and create a valid array of input and take the output and create something out of those numbers is left to the reader. But if you work with it a little bit, this is text embedding method, you can actually do something really interesting, which is inferencing inside of your code. So this is a tokenizer that changes the text into tokens. You give it also an attention mask, which I'm not going to explain right now, but this is basically an array of ones, so nothing fancy. And then you take a model, you give it the input, you give it the attention mask, and you will get an embedding. And the interesting part for this text embedding is that there is a second model which can do image embedding, which also gets like, here is an image, we pre-process it, which is basically resize it. And then we give this image to the model, and we get a different embedding. But those two embeddings live in the same space, which means that they are similar. If I find a string cat, and I find an image of the cat which is not labeled, those two vectors will be actually very close to one another, which means that we can search for them. And this demo works for sure, because I tested it just before the presentation. Here is a very simple application that has like 600 images. And it's a very small set of images, but still. I can look for a cat. And I got some cats. And those cats, the images themselves, are not labeled. The model, what it does is it takes the string cat, it creates an embedding, and then it finds embeddings for images which are closely related to this one. I can do this in any language. I can do pies. And we'll find me some dogs, except for this one because this is cat, but it's AI, so you never know what you get. You can add some extra info. Maybe I want some sunshine, or maybe I want some tropical forest. Maybe I want to say it in Polish. You don't get the same results because the translation is slightly different embedding, but you'll get very similar results in terms of similarity. I can do some more crazy languages, like, I don't know, let's do Shiro Neko. Who speaks Japanese? It's supposed to be white cat, but the dog is also very close, maybe because of the ears. Yeah, so you can use multiple different languages, and it will actually work with your text and find image that is similar to this text, even though none of those images were labeled in any way. There is no text in the database. There are just embeddings for those images, and at no point I will be doing anything to those images to actually describe them. And I can also upload an image. let's say this one, Ruby Warsaw. And if I refresh it, it runs in the background. It will find me similar images in my database to this image. So I'm searching with image for another image. And it will also know that these images are similar. This one I did for the demo in Paris, and this one I did in Berlin. But you can also find things that are similar according to the embedding. So you can do pretty cool things with very little code, because it's 30 lines of code to do the embedding, and it's like one SQL query to compare two embeddings. And this is machine learning in practice. You can with very little code, you can do interesting things if you already have a model. And this model is downloaded from Hugging Face. It's nothing special. I haven't fine-tuned it. I haven't done anything interesting to it yet. But out of the box, it gives you a very good experience on doing semantic search inside your application without any kind of external service. Going back to the presentation, this is an interesting, because most people will ask me if those Onyx models, they have actually anything to do with LLMs. And yes, they do. We just usually hide the complexity with running LLM. But you could do LLM in Onyx. This is pseudocode, which basically loops over some inferencing of the model, which will give us a token. And if the token is end of sequence, you basically just stop encoding and you end the LLM's predictions. But if not, you append to the token and you do it again. And by the way, because this is a fixed size array, you have to drop some of it if you run over the context. And this inference of a neural network is the reason why the models have a fixed sized context window. It's because you basically pass an array of tokens. And the array is always the same size. You just pad it with empty tokens if it's too small. But you can't give it something that is bigger than the expected input size. Please do not copy this code, because this is basically pseudocode. There are more intricacies to running LLMs. But this gives you an idea on how the Onyx model relates to LLMs. There are some other options in Ruby. You can shell out, which is basically called something from shell. You can use PyCall, which basically will call Python in a virtual machine. You can use PyTorch models, but the easiest way to do it is still Onyx Converter, which is a library that converts a PyTorch model into Onyx. So you can run it natively without having rely on Torch being installed. Same goes for TensorFlow, but TensorFlow is even more abundant, so Onyx converters are even more important. And I can show you one more demo for this. So this one is also interesting. Maybe I can find something that will zoom it a little bit better. Can you see my screen quite well? Is it readable? Okay, so this is a very short program that basically will read the input from the microphone, and it will run a voice sentiment, so emotion analysis Onyx model, every half a second for 3 seconds. So it will overlap a little bit. So you will get less than real time, but close to it voice emotion analysis. So if I run it, okay, so now I'm speaking neutrally, but I can also speak happier, and it will go up. I can do sad voice, and I hope I can actually get it to trigger the sad voice. Yeah, it's not very easy to trigger sad voice. And I can never trigger angry, because it's super difficult to do. I don't know why my voice just, it registers angry. Yeah, so once again, I couldn't do it in France. I could do sad, but not the angry voice, which is really sad. Sorry. No, still neutral. So this is around 100 lines of code. The actual running of the model is basically 20. There is very little to it. Yeah, so this is running the model, and this is decoding the array. Maybe I can zoom it a little bit. Yeah, so this is decoding the array to get which number corresponds to the result, which I can then map into emotions, which are a predefined array that are set in the model description. So there is very little code, and the most of this code here that you see, because there is a little bit more, is basically doing running this in loop in multiple threads, so you can get like the last 3 seconds, this 3 seconds, another 3 seconds, and do some average, so I can display this nice graph here. But the actual code which runs the models, it's very short, very easy, and you can find those examples how to run this models from Hugging Face. Even though they will be in Python, you can convert them to most languages that we use, including Ruby, including Java, including PHP, because there is an Onyx runner for PHP. So you don't really have to do anything special. You just download the model, run it, and see what happens. Going back to this, why though? Like, what's the reason for running all those models? It seems a little bit silly when you can do LLM for most of this stuff. But you can do interesting small AI and ML features. This is a quote from Ruby AI Discord, Ruby AI Builders Discord. That's the name of the Discord. And there was a guy who jumped in and asked how he can use Claude to tell if the document is rotated for OCR. Because that was the default mode of thinking for AI. Everything is an LLM, everything is a call to OpenAI, everything is a call to Claude to do something. But I just look at Hugging Face, and there is this tiny, tiny 1 megabyte model that I don't have a demo of it right now. But if you basically run this thing, it will tell you if document is rotated or not. And that's all the code. There is very little to it. And I didn't write this code. Claude did. I just told it, here is the model. I would like to have some command line tool that will tell me if which one of those 2 images is rotated or not. Please use it. And it wrote it the first time without any intervention from me as well. So you can have those problems that seem very difficult and require something like Claude, Gemini, requires some advanced machine learning and AI, but turns out that somebody already did the work, and there is a repository of those models which you can actually use. And next time you stumble upon this thing, do you need a specialized model? Just take a look at what's available on Hugging Face. This is, for example, MedGemma, which is a tiny model that knows stuff about, they just fine-tune a small Gemma that knows stuff about medical, various medical domains, but it can also read, for example, X-ray or MRI images, and you can mark stuff on it. And it's available for free from Google. You can just take this model, run it, and give it an X-ray, and it will try to find some anomalies. You can find some specialized models for embeddings for medical data. You can find stuff that is really, really amazingly advanced for next to nothing or even free. There are some other benefits. If you don't have to call OpenAI while you're responding to user call, you don't do HTTP call while doing HTTP call, which means the latency is much better. If you need something like HIPAA compliance or some other, let's say, financial compliance, if you run everything yourself, it's much easier to provide this because you don't have to sign a specialized deal with OpenAI or, I don't know, whoever else. And you pay for compute, not tokens. So if you have something like a Mac Mini and you run it in cloud, which you can do now because you can just rent a Mac in cloud, you basically have a ML computer with neural engine to run big models on your own hardware, and you can run as much as you want because you're not paying for tokens. It will run 24/7. And for Ruby, LLMs are great. There is much more, and Ruby is definitely ready for it. So next time you're working with some problem that requires machine learning or AI, think of Hugging Face as your second Ruby gems, and because Ruby gems is no longer trendy, as your second gem co-op for those of you guys who follow the drama. Thank you very much. And I was told to put this here, so I'm putting this here. Thanks, Kaya. Are there any questions?
You need to add ties to the pictures in your database because when you are searching for kiss, then I wonder how many blocks and how many bytes there will be.
That is true. Like if you're doing multilingual search for embeddings, there is an language detection, and there will be overlap. And we actually ran into this problem once. I remember specifically that I don't remember the language, but the name for bread and for rock in two languages is the same, so we were getting very random results. And sometimes it's better to use a few smaller models, which will be embedding into different language, or you do some language detection, or you use the user language and translate and then embed. But overall, if you don't know what the user language is because they're visiting the website the first time and they are typing something, it's better to show them some results for PS instead of no results. Okay?
Yeah, when it comes to the offline models and their execution, have you checked WebLLM or WebGPU to run these models in the browser?
I used WebGPU to run Whisper in browser, and it worked pretty well. It could transcribe something using just the browser, but it's extremely device dependent. So if somebody was using older Android phone or some terrible student laptop, it is definitely too slow. So you have to do some benchmarking first before you can run them, which kind of defeats the purpose for now, but it will get better over time. And if you're talking about something like tiny models, like that 1 megabyte model for detecting rotation of a document, that would work in JavaScript in browser without any issues, including downloading the model because it's just 1 megabyte. Oh, that's another thing. If you're running something like Whisper, it's 300 megabytes. Do you really want a user to download 300 megabytes on their phone? You can do it, but they won't be happy if they're roaming. So, yeah, cool idea, but very niche use cases because of some restrictions right now in hardware and networking. Any other questions?
What's this drama with hiding places?
With Ruby gems. So Ruby gems is a Ruby repository that is run by a group of people, and
So it's a drama within
within Ruby community. There is this website which is really funny, but I don't have the link right now, and you can probably find it. How many days till the last Ruby drama? And it was going up for a very long time. We were drama free for years. And they did a hostile takeover of Ruby gems, and now we're back to a month. Any other questions? Thank you very much.